In numerical linear algebra, it is an algorithm for determining the solution of diagonally dominant system of linear equation. So what is diagonally dominant system of linear equation? It defined as in mathematics, a matrix is said to be diagonally dominant if for every row of the matrix the magnitude of the diagonal entry in a row is larger than or equal to the sum of magnitude of all other non-diagonal entries in that row. So what does it mean? Our question is 4x plus y plus 3z is equal to 17, x plus 5y plus z is equal to 14, 2x minus y plus 8z is equal to 12. When we make matrix of that question, it will be like that: 4 1 3 1 5 1 2 minus 1 8. So this is diagonally dominant matrix. In its first row you can see that 4 is greater than 1 and 3, so this row is diagonally dominant. In the other row 5 is greater than 1 and 1, so this row is diagonally dominant by 5, and in the third row 8 is diagonally dominant by other two. So this is the diagonal and this whole matrix is diagonally dominant. So when we will gonna solve our question, we make this equation from our question that x is equal to 17 over 4 minus y over 4 minus 3z over 4 and so on. On substituting, x is equal to y and z is equal to x is equal to y is equal to z is equal to 0. So we put y and z 0 in our first row. So we get x is equal to 17 by 4. Next we will put x and z is equal to 0 in second row, so we can get 14 over 5. Next we can put x is equal to 0 and y is equal to 0 in our third row, so we get z is equal to 3 over 2. Again substituting these values which we get from our first equation, we get x is equal to 17 over 4, y is equal to 14 over 5, z is equal to 3 over 2. So we put these three values in our equation to get another x like that. So we put x is equal to 17 over 4 minus 7 over 10. When we put 14 over 5 in this fraction, we get minus 7 over 10. When we put 3 over 2 in this fraction, we get 9 over 8. So again we get x is equal to 97 over 40 and y is equal to this and z is equal to this. We put again these equations, we put again these values to get another x, y and z. So here we are. We repeat this process and make some iterations until we get values of x, y and z which are nearer to the whole number. Means 3.05 can approximate to 3, 2.03 can approximate to 2, and 1.02 can approximate to 1. So these are our values. So we would stop at that. So that's how we gonna solve Jacobi's method. Hope you enjoy. Thank you.